Thank you very much. Just in case you are kind of expecting the head of developer relations, I'm only the head of developer relations for Android machine learning, not all of Android. Oh. Hey.
Okay, let me just clarify for the audience that are watching the video that I am not the overall head of Android developer relations. Sorry, I only look after the Android machine learning part. And if you want to kind of follow me on Twitter, then my Twitter handle is Hoitab, H-O-I-T-A-B, for the latest on Android machine learning. So when I first kind of come over for various conferences in Asia, and they say, hey, why don't you tell us more about what you do and Android machine learning, what's the latest happening? My first draft of the presentation looks something like this. It's like, hey, let me just do a corporate presentation with lots of boxes, et cetera, et cetera. And I go, well, actually, that's rather boring. So I scrap all of that. But instead, what I want to tell you is basically my own personal experience. So this role for me is new. So I have done machine learning before, and I have worked on Android for 5 years, 5+ years. But the role of Android machine learning for me is new. And I've only really just started last October in terms of putting machine learning and Android together. And during that time, I find that there were a number of surprises when I talk to developers. And also during my time basically learning the various topics within Android machine learning. So today I want to share kind of a little bit of my own personal journey, kind of the dark alleys I've gone down, and things that I didn't really thought about at the beginning. And hopefully you'll learn something in this talk that will kind of help you short circuit all of that. And after the talk, I would really welcome kind of any feedback, or if you come over, we can have a chat. If you have any ideas about Android machine learning, I'm here, so please do ask questions. So the first myth that I want to basically debunk a little bit is that, hey, Android may not be powerful enough for machine learning. And this is not coming from nowhere. This kind of impression comes from we love our Google Cloud platform, by the way. But whenever people think about machine learning, this is quite often the first thing that they think about, which is, hey, you need teraflops and petaflops of processing power. There is no way they can fit that into your pocket. And even if you could, you probably need a nuclear power plant of some kind to run this kind of thing in your pocket. And what I find out after is that actually there is various stages of machine learning. And training, which is what those machines are really for, is only one part. There is the design part. How does machine learning fit into your app? The most common question that I get asked for Android machine learning isn't so much, hey, should I use neural network, or should I use nearest neighbor, or should I use random forest? It's none of that. It's basically, hey, my boss have told me to add machine learning to our app. Can you help? And that is a very design question. It is about, what is your app about? What is the problem that you're trying to solve here? And what are the opportunities within your app that can use machine learning? So design is really key in the whole process. And then also, after you have trained your model, there are two other phrases. So one is inference, the other one is deploy. So inference, what we mean by that is running your trained model on the device itself. So let's say you've trained your model to recognize where the eyes are, where the mouth is, and in inference, what we do is we say, hey, let's run that model that is pre-trained, all the weights are there, on the Android phone itself. And last but not least, deploy. So once you have got the model, you have various options as Android developers to deal with the deployment. So if you look at the various offering, one of the first things they can do is, of course, you can bundle your machine learning model within your phone APK. That's perfectly fine. The other two options, which I think people are less aware of, one, Google has an offering called Google Firebase ML Kit, whereby you can upload your own model, and then we can help you serve that model to your user. And what are the advantages of that? So two advantages. One is if you update your model more often than your app, then that means you can pump out new models kind of whenever you want. The second one is less obvious, which is around A/B testing. So machine learning is no different to any other functionality within your app. Sometimes you might go, hey, I want to try out these two models in real life and see which one runs better. And by basically having your model hosted in the cloud and then basically downloading it to a user, you can essentially do A/B testing within your user base. Another way that you can package your model differently is, of course, via app bundle. So if you packaged your machine learning app into one module and then basically you can deploy that as a separate part of your app, and that gives you a lot more flexibility. So coming back, as Android developers, we have a lot of opportunities aside from training new models to help with the deployment of machine learning in the for the user. Okay, log in again. Cool. So live demo of this working. Okay, so I've got a phone here that is basically just running a normal model. So this is the TF-Lite model of basically detecting the various elements on the screen. You can see that it is running live. I'm not sure. Oh, actually, the frame rate is pretty good. Normally, when I do this via Hangout, it really depends on kind of the network between the phone and the laptop itself. But today, it's actually pretty cool. So thank you, this university. It's a great network. So as you can see, this thing can detect objects live, and what it really enables us to do, and maybe I can show it in a couple of slides, is, let me just put that down and go back to the presentation, is that it can actually enable new user experiences. So before we go on to that, I just want to kind of perhaps go over some of the recent advances that we've made. So one of them is with Android Q, for example, we have improved the NNAPI platform, or the neural network APIs. So it basically takes better use of any processor that you have on your phone. So I'm guessing all of you would have been quite familiar with the graphics processing unit, but for some of the latest phones, we also have DPUs, digital signal processor, and neural processing unit as well, NPU. And those are really helpful in not only accelerating your model, but also reducing amount of energy use. So what does it look like in terms of results? In this case, we are seeing a 9x latency reduction, for example, with the ML Kit face detection algorithm. And previously, if you look at 495 milliseconds, that means you can probably get 2 frames per second, which is not a great user experience. But after the acceleration, we're getting it down to 55. So you're getting tens of frames per second, and the user can basically interact with it a lot more. As I said, performance is not only about latency. The other one is about the amount of energy used as well. So in this case, we're running the Google Lens OCR, optical character recognition. And the model that we're running here is the dense recognition. So it's not about just the one-word row sign, but if you're pointing it at a document, it can recognize the various lines of text and paragraphs. And this, we're seeing a 3.7, close to 4x reduction in energy use. So apart from kind of the technical improvement, we have also learned a number of things. And one of them is, actually, this is more like technical design helps. So thoughtful technical design helps. When we were running the ML Kit face detection on, this was a Lexus 5X, so a phone that is, I think, 4, maybe even 5 years old now. And as you can see, the result wasn't very smooth. And one of the reason here is because we have the camera preview running on the bottom layer, and then we have the analysis result basically drawing on top of it in a separate layer. And what it results in is, as the user move, you will actually notice it. You might not notice it on higher performance devices, but when you are kind of using it on a slightly older device, this kind of things happen. And what we've learned is, hey, why don't we just combine the two? Because yes, we can pipe through preview a lot faster, but if the purpose of your app is, for example, adding, I don't know, funny eye mustaches onto the user, then what is really helpful is basically the massage is right on top of the mouth of the user, and the funny eyebrows, etc. It's not just kind of drawing it somewhere on the screen. So in this design, what we have done is we have basically combined the two and wait and not display the camera preview until we have the analysis result. And in terms of code, this is what it looks like. This is actually in the MLKit sample. I will not go through all of it, but the important thing here that I want to highlight is basically this bit about having the original camera image. So what this does is it will wait until the analysis is done before it renders both that camera original image as well as the analysis on top. And I would strongly encourage you to do something like this. The frame rate is exactly the same. It's actually a lot more responsive from the user's perspective, but the result looks a lot better. Another thing that I really want to highlight is, for example, even on the least performant devices, for example, the wearables where there are a lot of constraints in terms of the processing power that we can put in, the amount of battery that we can put in. Google have actually deployed their first Mandarin Chinese or simplified Chinese on-device model on Wear OS itself. So it can go down as low as that. And the other lesson in this particular model that we've learned is quite often in machine learning, we go, hey, what is the highest confidence, the top one result? But in this case, what you'll notice is actually is more than just one, because quite often in replies, the machine doesn't predict for you and say, hey, do you want to come for dinner? The answer ought to be, yes, no, maybe not sure, maybe other kind of replies. It shouldn't just be, hey, yes. You shouldn't really be answering for the user. And in those kind of cases, when you're optimizing for the top 3 or the top 5 result instead of the top 1, what we find is that actually sometimes your model could be slightly smaller, and also the kind of the amount of processing that you need to do to get to good top 3 or top 5 results may be very different compared to if you want to get to the top 1 result. Because in the case of smart replies, to get to a good top 1 result, essentially you need to know what the user is thinking, not just possible replies to the question. So that is very, very different questions that we're asking. So another lesson learned here is that sometimes consider your top 3 to top 5 accuracy as the goal rather than the top 1. And to help you to think about some of the design problems that you might face, we have actually launched this People plus AI Guidebook. And this is done by the Google design team. They basically went around the various teams within Google and just see basically what are the different lessons that they've learned while they're designed. My personal favorite here is basically actually the last one, error and graceful failure. So I'm sure that a lot of you have gone through technical interviews, etc., where the interviewer is expecting you to think about edge cases of your algorithm or your flow. And in traditional programming, those are more like I said, edge cases, and those are not the main flow. So you basically code the main flow, and then you might kind of think about it on the side and say, hey, that's something that I need to take care of. But in machine learning, especially if you're getting machine learning to do your to grasp the input for you, that could be quite different. Your edge cases can actually become your main flow. So consider this particular example where, for example, you're sending an invite to a party and say, hey, should we start this party at 3? In traditional programming, you might put 2 buttons down and say yes or no. And the outcome is very deterministic. They can't do anything else. But imagine if you have like a voice input. So instead of having yes, no, if the user go, well, I'm not sure, I think 5 p.m. is better, then it's like, whoa, what's going on here? Is it a yes or is it a no? And that's something that I think as developers we need to get used to. Some of those edge cases that we previously only pay a little bit of attention to, and we might just pop up an error and say, you should really select yes or no, now becomes the main flow of the application itself. So you might need to kind of consider a lot more of the different answers that your user might give you. This is all in the People plus AI Guidebook. So another thing that we have published is the material design plus machine learning, cross machine learning. You can get access to it there, where we put down specific examples and specific code that you can actually copy. So in this case, it's a object detection model. And once it has detected the particular object, then it will basically go to the back end and then see how does it match up with your own catalog. And it can show you things like pricing, what sizes are available, etc. So you can see from the demo that I did earlier, where I just kind of mark out all the different objects on the screen, we can actually turn it into something that you can see people using kind of in shops, where they go, oh, this pair of trainers looks nice. Let me basically detect that and then say, oh, does it have it in my size? And the other thing that it can do is to say, hey, does it have it in my color? And how much does it cost? So this can really change the kind of user experiences that you can build within your app. Okay, so that's the first myth, hopefully done, which is Android is powerful enough for machine learning. So the second one is machine learning is not for me, it's for people with PhDs. So how many of you have PhDs? You can say it. Okay, at Google we love PhDs, but I do not have a PhD myself. Yet I work in machine learning, and in order to scale, we basically need to move with the developer kind of ecosystem as well. And hopefully I can show you that we don't necessarily, we love our PhDs, they do push things forward, but in a lot of cases you don't actually need that. So the first thing that I want to highlight is, of course, a lot of you know the ML Kit, which is Google's machine learning SDK for mobile. And last year we launched with vision and custom model. So, and I think this morning there was a talk on face detection. So if you have not checked it out, please do on the talk from this morning. And then the second thing that I mentioned before was model serving. So basically you upload your custom model or maybe multiple model that you want to A/B test into Google's infrastructure, and we'll help you serve that to your app. This is no different. That is kind of no different to a lot of the Firebase offering that we give you. And then in Q1 this year, that is new that we've launched is two things: language identification and smart replies. So language identification, what it does is you feed it a couple of words or maybe a sentence or as much of your text as possible, and then it will come back and tell you which language it is. And you might think, wait, what? How is that useful? And so I can tell you the best use for that for this is, for example, a lot of you might build, say, natural language processing algorithms. Things that will be able to help answer users' question. Let's say you built it in for Vietnamese. So before you pipe anything into your algorithm, you should check that the input is actually in Vietnamese, because otherwise you might get all kinds of really unexpected output. And if your app is for consumer use, some of those bad output might not be very pleasant, and you might find that your app kind of ended up on a blog post, on or in an article because you are trying to, for example, process, English language, us if it is in Vietnamese. So something like that is super helpful for you to help you essentially gate any input into your model. And then the second one is smart replies, which I will show you how it works. So I've basically just coded up a very simple sample app where I just take a question and then, or maybe like a sentence, and then as you can see, the model will come back with, hey, plausible replies, and then you can kind of choose one of those. The model actually support a conversation kind of mode, and it will, and if you are building, let's say you have a chat function within your app, and you have, say, a history of the last 10 conversation, feed them all in, and it will give you basically a much better prediction than if you just give it kind of the one string or the latest string. Everything that you see here is done on device. The conversation itself is not sent to Google. And so your, in terms of privacy, your privacy is protected from that regard. So this model actually we got pretty early, and we go, yes, we can just push it out. But a little bit of a backstory. What happened was we gave this model to our partner, this new API, and they come back and say, actually, some of your replies was not great. And we go, what? What are you talking about? Our replies are fantastic. And then they go, well, actually, on some of the sensitive topics, we prefer you not to answer or not to put in any smart replies at all. So how many of you know about Brexit or what Brexit is? Okay, a couple of you, maybe half. So there is this super contentious event going on in the UK, which is where I come from, where the UK is trying to basically extract itself from the European Union. And this is an extremely sensitive topic. So what would happen if you ask smart replies, what do you think of Brexit? It would actually do this. So it would basically say, well, actually, I'm not sure. I basically would give you no reply at all. And this is the kind of things that, that took the Google team actually a couple months to look into. And that's something that I think, yes, if you're doing a startup and you're trying to create a model, I would strongly encourage that. But then the other thing is I will also say, if you're trying to create a smart replies model yourself, look at those kind of failure cases and see whether it actually it might deliver a technically correct experience, but does it deliver a good experience? And hopefully what we have shown you here is that the MLKit team have taken a lot of care in terms of how they craft their model and their responses. And you can use it for free. So that's smart replies from MLKit. And the user engagement, this is something that we talked about at Google I/O, is that the user engagement is increasing. So the number of MLKit session is growing at around 60% per month in the main time frame. And at Google I/O, we basically launched a couple of new functions as well. Sorry. And these are it. So let me go through some of them. So the example that I've shown you earlier about object detection and tracking, we have actually made it extremely easy to use. So the first demo that I show you is basically the raw, or one of the raw models that the TensorFlow have published. By all means, if you want to use that model, you can. But with this model, we have actually done a lot of work for you. So how does it work? So the first thing is you basically feed in the camera stream into the MLKit API. And this is super helpful. So what we have done is we have actually defined a couple of categories up there where we go, hey, are you looking for home goods or fashion goods? So for example, with our partner Adidas, where they're selling trainers, then fashion goods will be fantastic. So you basically exclude the other objects that the algorithm detects, and it only detects things like T-shirt or trainers, etc. And if you don't know, there is also a category that I didn't put up there, which is called unknown, where it will just pick out the most prominent object that the user is looking at. So this is something that to really help you basically cut down on the amount of noise that you might get from the algorithm. And then what you can then do is to basically crop that particular object and then send it to something like the Google Cloud Vision product search. For this one, you can do it yourself if you're not using Google Cloud. Alternatively, you can also use your own on-device image labeling if you prefer as well, image classification. But the power in here of combining on-device and cloud model is that by connecting to the back end of your cloud, you basically can find out things like, hey, is this particular object or is this particular product available in other sizes? Is it available in other color? What kind of pricing it is? And those kind of information tend to be in Google Cloud. And if you're interested in building this, at least I'm quite proud of my team. So I'm really proud of the experiences that they've created in terms of how smooth that whole user experience is. And if you want to basically get the same thing, there is code behind this particular example. If you just search for material design and ML kit, then you can actually get to the code on GitHub behind this. So if you're designing something like this, you don't need to write everything from scratch. You can just download the code behind this. Next, translate. So this is one of my personal favorite, where you can leverage, again, Google's machine learning expertise between 59 different languages, and you could basically run the same model as Google Translate offline. And it is all free, and it fully runs on device. Similar to Smart Replies, we do not hold a copy of your conversation. So again, on the privacy front, there is no worry there. And if I think about my experiences here in Vietnam, when I call up one of the shared rides using a very favorite app that all of you use, I'm sure, a local app, call up my share ride. What I realize is when I type in my reply, it get automatically translated for the driver and vice versa. And that's something that I find really helpful. So if you have something like that in your app, it could be a chat function that maybe your part of your company is supporting your customers, then something like this could be super helpful. And you can also use it together with the language identification as well. So for example, if you have a customer that is German, then you can detect that, oh, that person or the language they're speaking is Germany, and then you can use the translate function to translate their conversation. Yay, so to continue the theme of using pre-made libraries, apart from MLKit, we have also built some APIs into our platform that helps you with speech. So I think this is a live demo, yay, okay. Cool, okay, let's go back to live demo. Speech. Okay, let's see if it works. I'm really happy to be here in Vietnam. Yay, so it just dictates it. This is a sample app that was created, and it seems to have no problem recognizing my English. Yay, okay, so, and it can also speak back to you as well.
I'm really happy to be here in Vietnam.
Can you hear that? Cool, yay. All right, so this is the risky thing that I'm going to do. So I'm going to switch to a new language, and I will need my beautiful, beautiful helper to help me. If you press and then speak.
Chúc mọi người một buổi chiều vui vẻ.
All right. And they can read it back as well. Is that correct? Yes. Okay. Great.
Chúc mọi người một buổi chiều vui vẻ.
All right. He reassured me that that was not something rude, so hopefully it was all right. Cool. So how is it done? And more importantly, how many of your users can actually use this? So when I demonstrated this particular function, I'll ask developer, hey, which version of Android will you need for this? And I would say around 95% of developers, maybe even 99% will say it's ice cream sandwich or above. And the truth is actually going back a lot more than that. So 10 years ago at Google I/O, in fact, it's so old that if you want to see this demo, it's in part 9 of the keynote. Because at that stage, YouTube cannot support video that's longer than 10 minutes. So you need to go to part 9 of this, and then you will be able to see a demo from 10 years ago. And I think this is text-to-speech. And then in terms of the speech recognizer, in terms of dictating the text, we launched it back in API level 8. So as far as your user base is concerned, it should cover 100% of your user base. So I would say, please do experiment. We do not support the over 100 language that the language ID does, but as you have seen, when I try Vietnamese, it seems to work. So, so maybe it does support quite a wide range of language. So if you, please do try it and see what happens. So how is it done? So there are 7 steps. The first step is you can create a recognition listener. And the first thing that I would encourage you to do is to basically show the partial result. So as the user is talking, the user experience that we want to provide is to show them, hey, we're listening to you, and also we're responding to your input. So by showing the partial result as it dictates, then it really helps. And as a side note, when I first coded this particular demo app, I'm not a designer, so I just go, hey, I should just center the text. So instead of left align or start align, I'll just do center align. But then what I realize is if you do that with partial result, then your text basically jumps around, because as new word comes in, then if you center align your text, then basically it just kind of shifts it around. And as a result, it's a lot harder to read when you're doing color partial results. And this is something that, again, I would encourage you to try it out. By having or by leveraging color machine learning, you might get very different user experiences. And it's only by experimenting that you find out kind of those little points. Another way to show your user that you're listening is by just showing them the noise level. So on RMS change is the method that you want, and then you can kind of do the Google kind of bubble effects or the Google Assistant effects by animating according to the noise level that you're hearing. Finally, when you get the result, you can just get it from the array that is from the result. The top result will be the one with the highest confidence. And optionally, you can also loop through the rest. So in the Vietnamese demo, we only saw like one result, but sometimes in other demo, as for example, in the English result, let me just switch back. So in the English result here, we basically see some alternative. And you can see that those are basically by and large the same thing. But for example, it might spell I am, I''am, or spell out fully, I-am. Or Vietnam, it might spell it in one word or 2 words. So there may be some variety. It depends on kind of how you're processing the output as to whether you want to basically take a look into the rest of the result. So that's the optional loop through the rest of the result. And in order to use it in on create, then you basically create a copy of the speech recognizer. and you also create a speaking intent, feeding in a bunch of options. And here, the two options I want to highlight is one, switch on the partial result. As I said, that's just good user experience in terms of showing the user that you're listening to them. And then secondly, yay, you can actually specify Vietnamese as being the language. So yeah, please do that. And that will also kind of help you, again, deal with the output if you can specify the language to begin with. And when you're ready, so when I press on that button, it runs basically that line of code and say, hey, start speaking, and feeding in the intent. And that's all it is, 7 steps to basically do voice dictation on Android. Another way, so apart from kind of the platform using MLKit, another way that you can get started with machine learning is to basically follow kind of well understood paths. So in this particular example, what I have is essentially an input image, a turtle, and I really want to basically convert this photo into this kind of style. And the output is this. And it is something that is called image stylization. And if you search it using your favorite search engine, then something like this will come up. A lot of it comes with instructions. Nowadays, even more come with basically Collab notebooks that will basically essentially have code in it, and you can just press the play button to run it. And the other thing that I want to highlight, so this is a product from Google called Collab, collab.research.google.com. The other thing that I want to highlight here is that if you do run it, it's actually a lot faster than potentially your own desktop, certainly faster than my notebook. One of the reasons is, so for example, at work, I have a reasonable workstation, you know. I work at Google, you know, they just go, hey, have as much RAM as you want. And so I can't really complain about the spec of a machine. But one thing that I could complain about is the amount of GPU that I have on my machine. So the memory on my GPU on my machine is 4 GB, but the instances of GPU that you can get on Collab for free, the last time I looked at it is 10 GB. Sorry. So what I find is when I run models on using kind of Google's cloud is actually a lot faster than if I run on my own machine. So sometimes, you know, just go and try it out and see how it goes. So what happens when I run this particular Collab using my own data? So this is my daughter. I think this picture is of her from about 2 years ago. She's now 8. So I think she was 6 back then. And I thought, hey, I want to basically turn this picture into beautiful kind of pencil drawing. So I just did that. I picked a pencil drawing image that I have, combined the two, and without changing a single line of code, this is what I get. But what you have noticed is that up there, and basically actually throughout the image, there are a lot of kind of square shapes that are odd. And then when I look at the original photo or the original style, what I find is, hey, there are books, kind of, there was a bookcase kind of behind a particular person, and there was a lot of angles in it. And the programmer within me go, well, actually, how can I solve that? Is it basically the algorithm not looking at the brushes kind of correctly or not getting the particular brush strokes correct? So I go, why don't I increase the resolution of both the input image and the style image by actually 4x? So the original algorithm runs at 512 by 512, and I go, hey, why don't I just double that to 1024, 1024? And then this is the second attempt that I've made. And as you can see, you know, basically I got rid of those squares at the top, and it is now a lot more natural. And I have to say that I didn't change a single thing about the particular model structure. I didn't change a single thing about, you know, how the different processes are run. I purely just changed the dimension. And even though that Python is not like my first language, as programmers, I would say that that's a pretty easy task. for a lot of you to, basically go through the scripts and then basically look at, hey, what is limiting the dimension, etc. So I would argue that there is a lot that you can already do and you can experiment with, even if you do not change the fundamental structures of that model. So all of this took me, say, about half a day. So right from search for the particular Collab that I want, to running it the first time, to iterating through the different kinds of code, to playing with different style. All this took me like half a day. So last but not least, machine learning needs a lot of data. And to be honest, again, a lot of this comes from the fact that quite often what you hear about machine learning performance is, oh, we have 1 million image, or we have a couple million examples, etc. And quite often what you hear is like, oh, the model isn't performing correctly. We need to find kind of more examples. Actually, there are other ways to solve the same problem. So one of the things that you can do is to leverage the technique of transfer learning. And we have actually productionized some of these offerings. So for example, today you can actually use something called ML Kit, AutoML Vision Edge, that will basically train your model for you. And what it does is it basically utilize your input and your label, and then build a model on top of an existing model, and basically produce a model that you can actually use in production. And this is what it looks like. Basically, you just need to upload your data set to the Firebase console alongside the labels. One of the ways that you could do that is to basically just upload a zip file with a directory structure. So the directory name will be the names of, or the label of the images contained within them. And then next, you just need to basically choose what kind of model you want, and it will basically give you an estimate on basically how it will run on, for example, in this case, a Pixel 1, and the size that it expects. Next, you specify the amount of compute that you want to use. So I think you get a 1 hour compute hour for free with us. But of course, you can basically choose a larger number if you want to pay. In terms of the kind of data that you put in, the first one is pretty important. The data need to be relevant. So it need to be basically mapped to something that you would expect in your real app. And then the other thing that I also get asked a lot is, how about the enterprise environment? And in this case, actually, the enterprise environment is fantastic because, let's say if you have pictures, or let's say you put an Android device that is basically looking down at your production line, then you can make sure that the lighting condition will be a certain thing. The background will be perhaps a conveyor belt. Whereas in a consumer application, you might need to be more careful because basically the consumer can pretty much put anything in front of the app. But if the app is being used in your production line or by your own workers, then you can control that a lot more. And last but not least, so the AutoML example that I've shown you is just one of many different transfer learning techniques that you could use. I would say that, for example, with image labeling, which was the example that we had before, starting at 50 plus photos per category, I would say is like the bare minimum, where let's say you're building a prototype to show your boss that hey, this can work. Then I would argue that around 50 photos you can start to get some result. In production models, we're seeing people using hundreds or thousands of images per category to basically go through the same process and get a production quality model. But what you will see here is that this is not the millions and billions of photos that people were first expecting. And yeah, and just coming back to this, in this particular case, we only have sample size of 1. I think this is one of my last slides. I'll go through it very quickly. So the first one is that, the last thought that I want to leave with you is machine learning is not a solution to every single problem. And sometimes by not using machine learning, you can save a lot of effort. And in this case, for example, in Gmail, when you say something is attached, and it didn't find any file, it would just say, hey, here's a warning. Sure, we can improve it with machine learning, but this may be, just as good. And before you start any machine learning project, I would kind of strongly recommend that you code up another method where you don't need to use machine learning and see whether your algorithm can actually beat that other method, because that's a pretty good benchmark to set. So just to kind of review, Android is ready for ML. You don't need a PhD for some of the use cases, and data need maybe less than you think. Last two links that I want to leave with is one is this one. So we have created a section on the developer.android.com with all the different offerings from Google. So you just need to go developer.android.com/ML to access that. And then I will also leave you a playlist. I would argue that you can skip the first video because I have spoken here. So you could just kind of skip that first video. Otherwise, it would be you'll be pretty bored. A lot of the material that I've just spoken about is in that first video. But I will encourage you to basically look at the rest of this YouTube playlist and ask me questions. So I think my time is way over. So let me just stand aside for the next speaker. But if you have any questions, please do DM me. So direct message me on Twitter. My handle is Hoi Lam. Thank you.